In this animation, we will introduce one of the techniques used to determine the structure of an unknown compound. And this technique is nuclear magnetic resonance spectroscopy, known as NMR spectroscopy. One of the types of NMR spectroscopy is proton NMR. So it's based on this nucleus of hydrogen. Proton NMR spectroscopy gives information about the different types of hydrogen atoms in molecules. It also tells us the relative amounts of each type of hydrogen atoms. For example, the hydrogen atoms attached to a methyl group or those to a hydroxyl group. It also tells us about their positions relative to each other. And this allows to determine the structure of organic compounds. Those nuclei have a property called the spin. They can behave as tiny magnets. The two spin states of such nuclei normally have the same energy as we can see here. So the two spins have exactly the same energy. However, in applied magnetic field, these two states have different energies. So let's increase the strength of the magnetic field and examine the difference in energy, delta E, between them. So now we will increase the magnetic field. We will increase the strength of the magnetic field. Notice how the difference in energy is increasing. So delta E is becoming greater. So if we decrease it, delta E will decrease. And if we increase the magnetic field, delta E will increase. Here we have the frequency. This energy difference, delta E, corresponds to the energies in radio frequency radiation. So in an applied magnetic field, H1 nuclei in a molecule can absorb or emit radio frequency energy corresponding to the magnetic field they experience. By jumping between the two energy states, hydrogen atoms in different parts of a molecule will experience slightly different magnetic fields because of their chemical environment. Their electron clouds shield them from the external field to different extents. These differences are in parts per million ppm. An NMR spectrum consists of a series of peaks representing different types of hydrogen atoms in a molecule. And if we are using carbon-13, for example, NMR, then the peaks will represent different carbon atoms in the molecule.